Hi, good evening, guys. This is Shoaib Sheikh from Let's Upgrade. So today we are here with a new program for you all: data structures and algorithm. Data structures and algorithm is a very important topic for every programmer and every individual to learn, and everyone programmer needs to have a very apt knowledge of data structures and algorithm to be very good at programming. For this course today we have with us Mr. Subrat Sir, Subrat Kumar Sway. Sir has been training student. Sir has 3+ experience in training students on online and offline arenas. Sir has been training over 10,000 students. Sir has skills like Sir is a master in languages like C, C++, Core Java, Python, database management system, that is SQL. And Sir has a BTech degree in computer science from Silicon Institute of Technology. So today we have with us Mr. Subrat sir, and I would like to hand over it to sir. Also, the attendance form will be raised at 6:45 and will be given it to you in the chat section and description. Make sure you mark your attendance, attend the whole lecture, and submit the assignments. I would like to hand over it to Ms. Subrat sir. Yes, sir. We can continue.
Hi everyone, good evening. So sorry for that. There was some technical issue. So I hope now you all are set and we are ready to go. Okay, so let me start with one question, guys. Okay, so let's say you have three options. One is your steam rice, that is plain rice, and one is fried rice, and other is, let's say, biryani. Okay, so which one would you go for? Like, which one would you like? Please write in the comment. Please write in the comment. Which one would you go for, guys? Let's say you have a work after 2 hours and you have these three options to have and go. Yeah, of course, with steam rice there will be some other stuff. I'm not getting into that. So you have these three options, as I said: the steam rice, biryani, and fried rice. So which one would you like to go on? Let me know in the comment section, guys. So I would follow up with that. Yeah, guys. I think most of you would go for biryani, right? Because biryani is it feels great, right? Okay, fine. Let me change the question here. Let me add some more condition here. Okay, yeah, biryani is love. I got to know. Yes, yes. So see, most of the people will say for biryani. I know. So okay, now I'm putting one more condition. Let's say you have to prepare it and then have it and go for your work, and you have just 2 hours time. Let's say, for example, then now which one you would prefer? If you have to prepare, then have it and then go for the work. Same rice, fried rice, biryani, same three option. Now which one would you go for? So you have to eat and like you have to prepare, have it and take some rest, obviously, because you are like you have some work to go. So which one would you now go for? Of course, we would go for steam rice now because it would take less time for preparation and we don't want to get into much trouble preparing biryani just to have, right? So we will have like steam rice. We would prepare it, prepare steam rice and have it, and we'll go for work happily. Later in our leisure time, we can have biryani, right? So okay, so what do we understand from here? Why we are going for this steam rice or the plain rice right now when we have the time constraint, as preparing steam rice will take less time, right? So I want to like I want you to relate this example to our concept called time complexity analysis. Okay, so I'll say word algorithm. I hope you all have heard this term algorithm, right? So what is algorithm? See, for any task, there would be number of ways to solve it. Let's say if you want to prepare a tea, there would be number of ways to do it, right? Okay, so some people do in a different way. Some people other people would do in a different way, right? So there are various ways to do a task, to solve a problem. There would be different ways, right? So all those ways, different ways, is nothing but algorithms. So to do a particular task, there are different algorithms. Got it? So we have to select the best. Like in our example, we selected steam rice as it would take less time. So similarly, we have to select the best algorithm. Got it? What do you mean by best algorithm? What do we mean by best algorithm? So there are two things, guys. Best algorithm is selected based on two things. One is time complexity and one is space complexity. So what do we mean by this space complexity and time complexity? Okay. So obviously time complexity, it would take how much time a program or an algorithm will take, and the other one will say how much space an algorithm would take. Got it? So got it? Okay. So bucks, right? But time is very expensive. So basically, we don't have time. If we get some free time, we would go for some Netflix and chill, or else we'll go for some other stuff. We'll hang out with our friends, right? So yeah, now like in the current scenario, it is not good to hang out in the out because of the corona situation. But yes, let me just go on with the example. So we are always short of time, right? We want our task to be completed within very less time, right? Got it? So there are two things here, as I said. One is space and one is time complexity. So we have to compromise between these two. If you are compromising space for time, like you'll have a better time complexity, or you may solve the problem in less time. Sometimes what will happen, we have to compromise with time complexity and have less space complexity. Okay, again, as have already said that now space is very cheap and plentifully available right now, so no one is like much worried about the space. We are mostly concerned about time. Got it? Okay, fine then. So I hope you like got this right about this example, how I taken this example of steam rice is biryani thing, and I've related this to this algorithm. Like, what is exactly algorithm? Basically, algorithm is nothing but some steps, finite number of steps to do a task, to complete, to solve a problem. Got it? So that is an algorithm. So for a particular task, for a given task, there would be like a number of different algorithms to solve, and among those algorithms, we have to select the best one. And how we select the best one? We select the best one by taking basically on the basis of this time complexity. Time complexity. Okay, sorry, my bad. Pardon my handwriting, guys. Okay, time complexity, and one more thing is space complexity. I hope you are able to understand whatever I'm scribbling here, literally scribbling here. So that's why I'm also saying it loud. So time complexity and space complexity are the two things, and we concluded that time complexity is the major concern here. Got it? Okay. So let's get into this time complexity basically. So as I said, what is time complexity? It would basically give you an idea of the order of time that would be taken by the algorithm to complete the task. Okay. So what happens as your input increases? Let's say n is the number of input. Okay. Number of input, or sometimes you can say value, like the how much, the quantity of that input. So if I am saying an array of n element, that is number of elements, how many input, number of input. But I'm saying, let's say I have to find factorial of n, so that would depend on the how large is the value, okay. I hope the thing is clear. Got it? So say this, uh, yeah, so n here, I'll say it is number of input to be on the like to make it easier. So what will happen? So what is this time complexity? I'll say it would give you the idea about the time order, the order of the time of the algorithm to solve the problem. As in, when the number of input increases. Okay, so basically we are tracking the behavior of the algorithm as the number of input increases. Got it? So it shows the growth of the algorithm basically, guys. So I hope this point is clear. So there are different notations actually to like show the time complexity or to write down the time complexity to identify the time complexity. So there are actually 5 asymptotic notation. See this. One is this big O, and the other one is your big omega. Okay. Then next thing is your theta. Sometimes it is also called as like big theta. Okay. Then we have this small o or little o. You can say small o or little o. Then similarly we have this small omega. Okay, small omega.
Sir,
So all these things are there. These 5 are there. There is no small theta and all. Uh, this is actually theta. Normally, you can call it as big theta, but fine. We would refer it as theta. Got it? Okay. So yeah, fine. And among this, actually, the small o and
Subrat
small
sir.
omega. Yeah,
So could you just close your OBS and turn on the camera from StreamYard? OBS is
yeah.
creating a lag.
Sure. I'll do it. Just a moment.
Yes, sir. You can just close the OBS scene.
Okay, just a moment then. Yeah, is it fine now?
Yes, sir. Perfect.
Okay. Okay. So, guys, is it now clearly visible? No lag, right? Okay. Yeah, guys, please, like, so say some like put some hands up or at least say yes if it's like clearly visible and like I'm loud and clear if I'm loud and clear. Yeah, fine, right? All the guys. Okay. So we are ready to continue, right? Fine then. So yeah. So I was saying about this. So we have this notations, okay, to like basically to identify the time complexity. There are different notation through which we indicate our time complexity. There are different things, different ways in which we notify for different scenarios. Actually, there is big O, there is big omega, there is theta, then there is small o and small omega. Okay, there is no small theta actually. This thing some people also call it as big theta, but there is no small theta. Got it? Among these 5, actually the small o and small omega, we don't use it. They are actually reserved for your research purposes. We are only concerned about these 3, but in this course, in this essential, we would be looking on this big O. Why big O? Why not big omega and why not theta? See this. Big O is used basically for worst case time complexity. Okay, so big O is used for worst case time complexity. Worst case time complexity. Okay, why we are concerned about worst case time complexity? Because in the worst case, we want to know that what time our algorithm would take. Okay, if you mark the intro video which we had premiered like in the yeah last evening, so you might have seen there I had told if you want to like write efficient code, then you need to understand the time complexity, right? So your algorithm is an efficient algorithm if it takes less time complexity, if it is solving the problem in less time. So we are concerned about the worst case time complexity. In worst case, what is the time taken by your algorithm? And you have to reduce it. Got it? Okay. So we are concerned about this big O. So we would mostly discuss things concerned with big O, guys. So let's proceed with some time complexities which we come across. Let's move forward. Let me clear the screen and I'll give some examples here. Okay. I hope this point is clear. Any doubt, guys? Up to this point? Yeah, you can say. Any doubt? If you have any doubt, you can just put up in the comment section. I am now basically looking at the comment section. Okay, fine then. So let's move on. And by the time, I hope someone would put up some question in the comment section. Fine. Okay, let's see some which programming language we are going to use. We would be following C, C++, mostly C. Yeah, for some example, I may take C++. Both maybe see the logic are almost same. The syntax is almost same. Little bit difference between C and C++. So to be very specific, if you ask me, then we would be using C. Okay, because it would be easier to understand the concept of data structure using C. Okay, that's why I have picked up the C language. So guys, okay, let's move on towards different types of, not types, various time complexities. Okay, so let's see this. First one I would discuss about is linear time complexity. What is linear? And there is one more thing, constant time complexity and linear time complexity. So what do we mean by this constant time complexity? Let me give you an example, guys. Then we would understand. Okay. Yeah. Okay. You have some doubt with worst case time complexity, right? Yeah. Let me. Okay. Then fine. Fine. I'll clarify that one first, and then I'll move on to this part, linear and constant time complexity. See, as I said, there are like various asymptotic notation, but we are concerned about, like, we would be using only this big O, and we would be using then big omega, then we would be using this theta, right? Theta, and the rest two are reserved for the research purposes. Among these three, in this essential course, we would be discussing about big O. Why? Because this notation is used to denote the worst case time complexity. Worst case. In worst case, what time would be taken by your algorithm? Okay, because as I've already said, efficiency, you have to write an efficient algorithm. It should take less time. I mean to say, in worst time it should take, in worst case it should take less time. Okay, so we have to focus on this big O, because big O denotes worst case time complexity, and this would be less for your algorithm. Got it? I hope that this point is clear. uh, let's move on to this various time complexities, guys, linear and constant. See, guys, I'm seeing some people are asking for Python. Use Python. Is Python? See this, guys. Data structure and algorithm is a concept, and you can implement it in any language. First of all, I'm picking C because it would be easier to understand the concept using C, and it would be useful for everyone. If you know C, or if you, let's say, know Python, and if you understand in C, then you can easily implement that using Python. Let's understand the concept first. Okay, let's understand. Once we understand the concept, we can implement in any language. Understood? Okay, there is no difference in logic in Python and C. Got it? So I hope the point is clear. So linear and constant C. So what is this constant time complexity? What do we mean by constant time complexity? Let's take a simple loop and let's understand this point. Let's say for I equal to 1, I less than equal to 100, and I plus plus. Okay, so if you, and let's say here there is a print statement. I'm in short form I'm writing PF, guys, don't get me wrong. This is printf. I'm just writing in a short form PF. Let's say I'm writing here, let's upgrade. Okay, my bad. Yeah, I'm not very good at handwriting, and again on this stylus. So I hope you manage that. So I equal to 1, I less than equal to 100, printf let's upgrade. So how many times this let's upgrade would be printed? 100 times, right? That is, we know this logic. This is a normal for loop, single for loop, and we have to see how many times this let's upgrade is printed. So if I ask you what is the time complexity of this algorithm, or of this code snippet, this is a code snippet we have taken. So what is the time complexity for this one? Then you would say 100 times, right? You would say it is 100 times. So you'll say basically big of 100. You can say, but we should not actually say big of 100, guys. Any constant value, 100 is a constant, so you would say this is actually constant time. And if it is a constant time, we may say big of c, where c is any constant, or we may say big of 1 is a constant time. So this is constant when it is known already that okay, this loop is running, or this operation is being done this many times, 10 times, 100 times, 1000 times. So this is your constant time complexity. What about linear? The same loop, if I change a bit, let's say for I equal to 1, I less than equal to n, and I plus plus. If I go for this, yeah, so same thing. Let's say printf hi. Okay, if I go for this, for I equal to 1, I less than equal to n, I plus plus, how many times I would be printed? You would say n times. What is the value of n? We don't know. That depends on the input of the user. User will take the value of n. Let's say I will take input as 50. So this loop will run 50 times. If I take input for n as 100, then this loop will run for 100 times. So that depends on the value of n, right? So we don't know exactly how many times this loop will run, or what time this algorithm or this code snippet will take to execute or to print high. That's where we go for this time complexity, guys. Okay, we have to denote it. Okay, what is the order of the time complexity? Time. So here it is very clear that time complexity actually depends on the value of n. And what is n? Input. So we are basically seeing or noticing the behavior of the algorithm as the number of input changes, or the input changes. Okay, got it. So it is very clear that this loop is nothing but order of n, big O of n. We say big O of n because it is dependent on sorry, n. It is dependent on n. If you change the value of n, the loop will run those many times. Very simple, right? Got it. So I hope this point is clear. One more thing, guys, let me tell you. I've seen many people doing this mistake. Don't go for time complexity thing for very less input. You'll say, okay, my input is 5, so order of 5. So it is big O of n, so it would be big O of 5. No, actually, what happens? We should not analyze, or we should not compare two algorithms on the basis of this time course analysis for very few input. No, we should be analyzing, or you should be comparing to algorithm when the input is very large, because initially for very few input it behaves differently. Actually, the behavior changes from a certain point. Okay, see this, guys. I'll quickly give you a graph actually, which we will like discuss in detail in our advanced course. We are planning for an advanced course, guys. So in detail we'll be discussing all this thing there, but as we have a time constraint here, so time complexity again comes here. So you have only like a very strict time constraint. So let me just quickly give you this idea. Okay, so see this. So let's say this is the x-axis is n graph, number of input, and this y-axis is nothing but your time complexity, which I denote as t of n. Okay, t of n is nothing but time complexity. So I have an algorithm. Okay, and the graph between this time complexity and number of input is denoted by fn, let's say, and it looks like maybe this. Yeah, let's say this is fn, which denotes the like basically the time complexity, you can say. Let's say as the n increases, fn shows this behavior. Okay, so what I would take is there would be another function. See, don't worry about this, guys. we would basically discuss this all this thing in detail when we move on to the advanced course. Let's say this, for example, okay, something a new function cgn, let's say. So this cgn, you say at this point, at this point, or you can say after this point onward, cgn, where c is a constant, gn is another function, is always greater than fn. So you can say this cgn is an outer bound. This is outer bound of fn. So fn, or the time complexity of the algorithm, will maximum it will take, in worst case it will take the cgn. So you can say it is time complexity in worst case is big O of gn, whatever function g of n is. Maybe g of n would be n or n square, that depends, that is a different case, that is a different thing here. Okay, see, don't get confused, guys. All this thing we would be discussing in detail in our advanced course. Okay, as here we have a time constraint, so I would quickly like pick some few example to make things clear. You understand? Okay, you don't like you not get like you'll not go disappointed in this class. Don't worry about that. So I'm just giving a brief idea about this. Okay, so at this point, why I'm drawing this graph is I want to notice few things. If you see this part, see, the behavior is different. And if you see this part after this point where I say this is n, let's say it is n naught, the different behavior is different. After this n naught onward, cgn is always greater than f of n. But before that, the behavior is different thing. That's why I said we should not compare two algorithms by assuming very less input. We should actually compare, assuming that okay, we have a very large set of input. Based on that, we should compare on the basis of time complexity. Got it? Okay, I hope the point is clear. Okay, fine. So let me clear this out. I hope this thing is clear, guys, about what is linear time complexity and what is this constant time complexity. This point, both this point are clear, right? Okay, so next, let's move on to one more type of complexity. Let me clear this out. I hope that's no doubt, guys. You can ask if you have any doubt. Okay, fine. See this. Okay, then. So moving on to the next complexity. We have done constant time complexity and we have done linear time complexity. Then let's say quadratic time complexity. Quadratic. So what do you mean by this quadratic time complexity? It is nothing but big of n square, order of this, order of n square. That is quadratic order, right? N square. So this is quadratic time complexity, guys. Let me pick some example basically to make you understand. So if I have a loop for I equal to 1, I less than equal to n, I plus plus, then if I have for j equal to 1, then j less than equal to n, and again j plus plus, and let's say here there is some statement, let's say hi. Okay, so if you see this now, this outer loop will run for n times and this inner loop will run for again n times. Got it? Okay, understood, right? So outer loop will run for n times, inner loop will run for n times. So you can say in total this will run for n square times. So order is big O of n square. Okay, so how we actually got n square? Okay, it is quite visible directly that it would be n square, but I want you to see this in this perspective. See this. So write I and j. See, I am telling you a way to solve some questions. See, um, normally in your placement drives or somewhere, what you will get is you will get a code snippet actually, and you would be asked what is the time complexity of this code snippet. So you have to understand how time complexity is found. That is why I am getting into this part, because this is very important. Yeah, I understand that the details behind this, what is big O exactly, what is big omega exactly, and what is theta is important for you. Yes, I understand that, but what I feel is this is more important, because the questions which you would get is, given a code snippet, you would be asked to find the time complexity, and you have to know the trick or the way to find out the time complexity of given code snippet. So see this, guys, how I am solving this. Please see this, and please focus here. Okay, fine. So up to this, guys, anything like you want me to explain again after this? Yeah, okay. Roshan says 50% syllabus at least. Okay, okay, fine. Yeah, see, Roshan, see, what I'm doing is I'm basically discussing the very important part in this class. Okay, I can go into detail, but we have a time constraint here. And if I miss out the important part, then there would be no point of you attending this session. You would just know the theory part, okay, which will not always help you, I'll say. I'm not saying it will not help you at all, but it will not always help you. Okay, don't worry about it. Go with the flow, you'll understand it fine. Okay, don't worry about it. So see this. Yeah, okay. Anything else? So what would be the time complexity if there is if statement inside a loop? Yeah, we would see a question based on this. Don't worry about it. Graph, you want me to explain that graph? Okay. Hmm. See this. That is not very important, but as you are asking, let me tell you guys quickly. So yeah, I'm not good at drawing. So this x-axis is n, number of input, and this y-axis is t of n, the time complexity, guys. Okay, t of n, time complexity. So see this. Your algorithm behaves in this way. Okay, let's say this is f of n. This is your algorithm. Okay, I'm taking a function called c into gn, where c is a constant, g is another function actually. Okay, let's say it behaves maybe this way, for example, c into g of n. G of n is another function, f of n is another function. So if you mark this point, this I'll call this point as n naught. Okay, after n naught, what is n naught? A certain number of input actually. After that point, beyond that point, you see c of gn is always greater than f of n, and before that point the behavior is different. That's why I said do not compare different algorithms assuming that there is a very less number of input. No, you should actually compare two algorithm when or assuming that there is a very large set of input in order to get the time complexity correct. Okay, am I clear now? Naveen, no issue if you don't know C++. Mostly or majorly it would be actually C. Okay, don't worry about it. Okay, I'll not force you to write C++. Don't worry about it. Okay, got it? Understood this point, guys? So n naught here, below n naught, the behavior would be different. After n naught onward, the behavior is different. Okay, c of gn or cgn is always greater than f of n. This cgn is the outer bound, guys. This I would say big O of g of n. In worst case, it would take maximum gn time. Okay, as it shows different behavior in when we have very less number of input, and it shows a different behavior after a certain point. That's why I say do not compare two algorithm assuming that assuming that it has very less number of input. Okay, we should always compare two algorithm assuming that there is a very large set of input. I hope the point is clear. Okay, right? So yes, Amal, we have to assume we have a very large set of input. Got it? Okay, so let's get back to this quadratic time complexity, guys. Let me erase this part. Okay, so see here we have a nested loop for I equal to 1, I less than equal to n. I plus plus for j equal to 1, j less than equal to n, j plus plus, and then we have a statement printf high. So basically, how many times this high would be printed? I think it's very clear. Let's say n value is 3, so high would be printed 9 times, right? Am I correct? 9 times. So let me tell you how exactly we are saying this is n square. It's very clear by looking at this code, you can say, okay, this outer loop will run for n times, and this, oh, my bad. Just a moment. Okay. Yeah, so this outer loop will run for n times, and the inner loop is running for n times. So total, it would be n square times. Okay, you can say, okay, but you can directly say here n square. But I want you to understand or see this in a different perspective, guys. How I am writing, please focus here. When I value is one, when I value is one, j loop will run for n times. Okay, got it? Very soon, Bhargav, Gopal, very soon you would be informed. No worries. So when I is 1, j loop will run for n times. When I equal to 2, j loop will run for n times. When I equal to 3, j loop will run for n times. Similarly, when I value is n, j will run for n times. So how many n? You just add them all. N plus n plus n plus how many times? N times. So total it would be n square. So I say this is big of n square, quadratic, right? So I hope this thing is correct, like, or this thing is clearly understood by you. Okay, so whatever we have completed till now, guys, we have seen like what is an algorithm, and how what is an algorithm we have seen. To perform a task or to solve a task, we know that we have different algorithms. Among those algorithms, we have to choose the best one. And how to choose the best? Based on two things: one is space complexity, one is time complexity. So space is plentifully available right now, so we are going for major concern is about time complexity. And yes, one more point I have already said that uh, we have to like compromise between these two. If you want to optimize space, then you have to compromise with time. If you have to optimize time, then you have to compromise with space. Got it? Yeah. Then we have seen a few types of time complexities. And yes, one more important point we have discussed that we should not compare two algorithm assuming that we have very less number of input. Got it? We should always compare assuming that okay, the number of input is very large. Understood? So here we have completed this n square, this quadratic time complexity. I want to basically discuss one more thing, that is logarithmic time complexity. We also have exponential time complexity. Okay. So give me a moment, guys. Yeah. Let me clear this. Yeah. Fine.
Sir,
Logarithmic.
Subrat sir,
Yeah. Sure. Say.
can you give me 5 minutes? We'll launch the attendance form.
Yeah. Yeah. Sure. Yeah. Sure.
Okay, guys. Guys, I'm putting the attendance form in the link section. Make sure you mark the attendance. Guys, please reload. The attendance form is working. We are also getting some responses from you guys. So please reload who is not able to fill the attendance form. The form is accepting responses.
Should we continue? Should we resume?
Yes, so we can continue. Thank you.
Okay, guys. So let's get back to what we were doing. Yeah, I was discussing this two time complexities. One is logarithmic and another is exponential. Okay, so say this logarithmic. Obviously, so we would say big of log n if your algorithm takes this log n order. We would say that it is uh, logarithmic time complexity, right? Big O of log n, right? Similarly, exponential. So it would be like order of you can say a to the power n. Okay, let's say we'll take a value of a 2 to the power n. So this is an exponential time complexity, big of 2 to the power n. Okay, let me give example of logarithmic. Okay, say this. Let me clear this out. Let me give you some few example. Okay, so here we have for I equal to, okay, my bad, for I equal to 1, I less than equal to n, and I into equal to 2, right? And there is some statement, let's say hi, same good hi. I equal to 1, I less than equal to n, I is incremented 2 times every time, right? So see this. First time I value is 1. What would be the value of I next time? 2, right? Next time I value would be 4 because we are multiplying 2 with I every time, and I is getting incremented by 2 times, you can say. Next time it would be 8, next time it would be 16, and so on. It would continue. Let's take a value of n. Let's say n value is 64. For example, we are taking n value as 64, but we should not take as 64. to understand like how this the order is going, we are taking some value here n as 64. Okay, so I value is now 16. So next time it would be 32. Then next time it would be 64, and we say we have reached the end of the loop because the condition is I less than equal to n. So now our I value is 64, which is equal to n. Okay, which is equal to n. So after this the loop will stop, obviously, because next time I value would be 128, which is greater than n, so our loop will stop. So you can say how many times our loop was executed. 6 times, right? 6 times. So this number of times this high is printed, or the number of times this loop got executed, that is nothing but your time complexity, guys. Okay, so you can say that the number of times this statement would be executed is our time complexity, the number of steps. In how many steps we reached 64? In 6 steps we reached 64. What is the relation between 6 and 64? 2 to the power 6 is actually 64. Okay, if you apply log on both sides, 6 is nothing but log 64. Okay, got it? Okay, fine. uh See, in first step we reach 2, second step we reach 4, third step we 8, fourth and fifth and sixth. In 6 steps we reach 64. Okay, so 6 is nothing but the log of 64, and 64 is nothing but n, right? We have assumed the value of n as 64, so log n. And what is 6? Number of steps, which I said number of steps is nothing but time complexity, so this is t of n. Time complexity, we found out that it is nothing but log of n. Okay, you can say it is big O of log n, logarithmic. One more way you can uh, see is for I equal to n, I greater than equal to 1, and then I divide equal to 2. Okay, I equal to n, I greater than equal to 1, I divide equal to 2. So what is the difference between this and this, guys? This and this one. Here we started from 1 and we incremented I value by 2 times. But here in this one we started from n and we are decrementing I by 2 times. Getting my point, guys? Okay, so it is just the reverse, like it's the same thing. Basically we started from 1 and reached 64. We'll now start from 64 and we'll reach 1. So 64, next time 32, next time 16, next time 8, next time 4, next time 2, next time 1. Same thing, right? In 6 steps we will reach we'll reach the end of the loop. Same thing, log n. Okay, even if you are incrementing 2 times, or even if you are decrementing it by 2 times, you will get the same log n, logarithmic time complexity. Okay, one question I came across in the comment section: do we use this time complexity only for loop? See, we don't only use for loop. Even we find a time complexity for recursion. You can have also for this loops, basically while and while loop and all. We can also apply for recursion. Basically the part which would decide the time. Okay, I hope you understood this example of logarithmic. So what I'm doing right now, what I'll do right now is I'll give a quick example, guys. Okay, I'll make you understand the few things, and yes, that would also answer a question asked by someone in the comment section: when we have if inside our code, what would happen with the time complexity? So let's see this. Okay, okay, so let's say I have some algorithm A, and inside it there is some condition. Let's say some condition. Okay, I'm not writing it what condition exactly, but there is some condition. If condition is true, then I'll print here high. Okay, else else inside it I would have a loop. Let's say for I equal to 1, I into I less than equal to n, I plus plus, and here printf hello is there, let's say. Okay, so this is if and this is for loop, this is else, and this is the end of our algorithm. Got it? So see this. So here we have this if else thing. Also we have this for loop. Okay. So we need to find out the time complexity of this algorithm. So what would happen? There are two possibility here. Okay. One is if the condition would be true, then this statement would be executed. In that case, what would be the time complexity? You would say there is only one statement, printf high, so it would take big O of one time complexity, constant time. What is the other possibility? This condition may be false, and we would come to this else part. If we come to this else part, if we ever come to this else part, then this loop would execute, right? Get executed. And how many times this loop is running? It's very easy again. Mark the condition. It is I square less than equal to n. So it is basically I less than equal to root n, right? So this loop will take big O of root n times. Got it? What is the worst case here? Big O of 1 or big O of root n? In the worst case, we'll go to else part and it would take big O of root n times. So we would say this algorithm time complexity is nothing but big O of root n, guys. Understood this? Okay, so this would be big of root n. So this is how we go for this. Instead of this for loop, if there is a recursive function, for example, let's say this algorithm A is a function here, right? Inside it will have a recursion. This A is a recursive function, let's say. Obviously, that would depend how many times the recursion is happening. That would decide the time. Okay, are you getting my point? Right? Fine. Difference between space and time complexity. How much space will your algorithm take? How much time will your algorithm take? That is what. Okay. If you're storing an array, so that is given array, so we will not consider it. To do the operation, what extra space are you taking? That is space complexity. Okay. Let's say reversing a string. If you are going in a method when you are creating one more string and copying it in a different order, then you are taking extra space. Okay, right? So the extra space what you are taking to do the operation, that is space complexity, and the time that is required by your algorithm to solve the problem is called as time complexity. I hope this point is also clear. Got it? Understood this? So this problem, let me just quickly repeat this. So if this condition is true, then we'll get into this one and high would be printed. So this is only one statement which will take constant time. But if we come to this else part, if this condition is false, then this loop would be executed and this loop will take big of root n times. Okay, big of root n times, because the condition is I square less than equal to n. So it would be I less than equal to root n times, which is like big of 1 or big of root n, big of root n. We will always go for worst case, guys. Okay, worst case, always. Even if you have here something statement here, printf hello. Okay, so this would take big O of 1, right? So which is greater actually, this one, or this one? Big O of root n, obviously. We'll go for big O of root n, whichever is higher in the worst case time complexity. Okay, so I hope you followed this. What I'll take is I'll take one more example, just one more example to make you follow the things which we have discussed till the point. Okay, let me do that. Just one more point. Let's do this, guys. Let's see one more question. Okay, fine. So A, there is an algorithm or function. A is 1 and S is 1. I'm just writing in an algorithm way. Okay, I'm not writing in a program way exactly. So don't say that the syntax is wrong and all. I'm just writing it, the algorithm, the steps basically. So basically here it is while S less than equal to N, A plus plus and S equal to S plus A. Okay, and let's say there would be a print statement high. So now you say how many times this loop will run, or you can say what is the time complexity for this one. Can anyone think of it and let me know in the comment section? Let me check out how many of you can answer the question correctly. Difference between best and worst. Obviously, in best case, how much time it would take. Okay, for example, um, if you are searching for your friend's home in a colony, it may be located, it may be the very first home in the colony, in the lane, let's say, or it may be at the last, like it may be the last house in the lane. So you have to go till the last, right? That is the best, worst and best case. Are you getting my point? If the house is the first house is your friend's home, that is the best case. If the last house is your friend's home, then that is the worst case. Got it? So everyone says here big O of n, but I'm afraid the answer for this is again big O of root n, guys. Let's see this quickly. Okay, and this is our last question for this evening. So let's focus here and understand this question. Okay, fine. Okay, for making you understand this point, I would take a value of n. Let's say n value is 10. Okay, s value is 1. What we are doing, if you mark this point, we are adding a with s. Okay, s is incremented by adding a to it, and every time we add a to s, before that we are incrementing a value. So what we would do is, basically, we are first time we are adding actually 2 s is 1, a is getting incremented, so a value is 1, a was 1, now it is 2, so we are adding 2, total is now 3, but it s value is now 3. So next time what we would add to it, we would add, okay, let me also write a value. A was 1, it got incremented to 2, and we added 2 here. Got it? Okay, then we'll again increment a, that is 3, and we'll add it up. So we got 9. Oh, sorry, my bad. It would be 6, right? Then again a would be incremented 4, and we'll add 4 to s value. That comes out to be 10, and we have taken n value as 10. So we would stop here, right? So basically what we have done here is 1 plus 2 plus 3 plus 4, and we reach the value of n, which is nothing but 10. Okay, so you can see here at fourth step, when we added 4, we reach the end of the loop. So here you can say, okay, this loop will run for n times, or 4 times, you can say. Not n times, sorry, 4 times you can say. But we are not here taking n value as 10, right? We have to think about a larger set. We have to write it in order of n. So how is that? So we added 2, we then added 3, we then added 4. Let's say at kth step, when we added k, we will reach n. Likewise, when in fourth step, when we added 4, we reached 10. 10 was the value of n. Now we don't know the value of n. So we are assuming in kth step, when we are adding k, we would reach n. Okay, got it? So what is this, guys? 1 plus 2 plus 3 plus 4 up to k. Addition of k natural numbers, right? That is your time complexity. Like that would give your actually give you time complexity, not exactly the total of this. See, when I said at kth step, when we add k, we will reach n. So number of steps is nothing but the time complexity. I have already said it. So we have to find the value of k, and how can we do it? It's very easy. See this. So here it is, addition of k natural number, and we know k into k plus 1 by 2. Addition of k natural number is nothing but k into k plus 1 by 2 is, we can compare it with n. So roughly we can say this is order of k square. I'm not writing it like expanding it k square plus k by 2. Okay, why? Because I am concerned with the worst case. So if it is k square plus k, I would go with this one because this is the highest. Okay, even if you have 3k square plus 7k plus 9, I would go with only k square. 3, this 7, this 9, these are constant. I will ignore them. And the highest degree, the term with highest degree is our major concern. So 6 k square. So I'm writing in order here, k square equal to n, and there it comes, k is nothing but root n. K is what? Number of steps. So this is your time complexity. We go root n. So I hope you followed this, guys. This would be root n. So is that fine, guys? Please let me know in the comment section. Is that fine? And if it is fine, we are good to end this sessions. Yeah, you would get notes. Okay, no problem on that part. Got it? Understood this? So let me just quickly like revise this what we did here. Okay, so here we added value of a with s every time. That is how s is getting incremented till the point when s will reach n. Okay, so what we are doing here, so we added 2, then we added 3 because a value was 3, then a value will become 4 and we'll add 4. So at kth step, when we add k, value of a would be k by that time. Let's assume that when we add k in kth step, we will reach n. So k is here nothing but the number of steps, which is the time complexity. Okay, we just need to find out the value of k. So here on the left hand side, we have seen it is 1 plus 2 plus 3 plus up to k. So it is nothing but addition of k natural numbers. So it would come out to be k into k plus 1 by 2, which is equivalent to n because we reached n by adding k. Now we can easily find out the value of k. Okay, I'm taking k square, the order, highest order, the term with highest degree would be taken here. Okay, in time complexity analysis. So k square is equivalent to like is equal to n. So k is basically root n, and k is our number of steps, which is actually time complexity. So time complexity comes out to be big of root n. Got it? Okay. Exponential, I'll give you some like that. Okay, that cannot be done here, guys. I'll give some actually for exponential. I need to go to this recursion thing. So that is actually a different thing. I don't want to get into that right now. You can, for example, you can go with Fibonacci. If you have done ever this Fibonacci, you can say this is exponential. Okay, I should say actually Fibonacci series. Okay, so this would actually take exponential time complexity. Okay, so guys, so assignment, it's time for assignment, right? So I'll give a question and you need to tell me, or let's say I'll give two questions and you'll need to find out the time complexity. Okay, based on whatever we have discussed. So let me give you the question. For, please note it down. For I equal to 1, j equal, sorry, not j, it should be I, I less than equal to n, I plus plus. For j equal to I, j less than equal to n, j plus plus. Okay, then let's say there is a printf high. So you need to find a time complexity for this code snippet. Okay, this is semicolon, this is j. Yeah, j equal to I, j less than equal to n, j plus plus. Fine. This is one thing, and other thing is for I equal to 1, I less than equal to n, I multiply equal to 2, or let's say 3. For j equal to 1, j less than equal to n, j plus plus. Okay, printf, let's say hello. So take this two question with you guys and do find the time complexity for these two code snippets. Okay, it would be easy, it would be very easy. Just take it and try to find out time complexity for these two questions. Okay, then fine, guys. So we are good to end this session. I hope you understood whatever we discussed in this session, and I hope I could meet up to your expectation. Like question, yeah, of course, there would be something like you need some more details, but due to this time constraint, we cannot actually put everything inside this session because we have just 1 hour here. So, guys. Okay, then just work on this two example. Try to find out the time complexity for this. We'll meet in the next session. So take care, guys. Have a good evening.
Thanks a lot, sir. It's been an amazing session with you. I hope we have
Thanks.
learned, all of us have learned something new today. So Guys, make sure you
And
mark your attendance, and the assignment will also be uploading a document with sir's question. You will get it in the community. Thank you for being here. We'll meet you tomorrow, same time. Thank you, sir.